Hi everyone, let's start with today's LeetCode challenge, which is seat reservation manager. So in this problem statement, we'll just have to implement the seat manager class. So as a constructor to this class, we will be given a number n, which is the number of seats, and we'll have to manage n seats which are numbered from 1 to n, and all the seats are initially available. And the other two functions are reserved and unreserved. So if the reserve function is called, the smallest numbered unreserved seat is reserved, and then we'll just have to return that number. And if unreserved function is called on any seat number, that seat number will be unreserved. Let's try to understand this problem using an example. So in this example, like we are given let's say m number of queries. The first one is seat manager, and the query value is 5. So we will be having 5 seats numbered from 1 to 5. So then two reserve function call are made, and then one unreserved call, and then further 4 reserve function calls are made, and after that unreserved function call. So let's try to simulate this example. So after the seat manager function is called, we'll just maintaining an array of 5 size. You can consider them as our seats. So after first two reserve call, when the first reserve call was made, we will just reserve the first seat. Okay, and then after that call, on the second reserve call, we'll just reserve the second number of seats, because we will have to reserve the smallest number seat available. So now, which is the smallest number seat available? We have 3 as available seat. So but we will just have to call unreserved function. So we will just unreserve the seat number which is given with the query, which is 2. So we will unreserve the 2 and mark it as a -1. After that 4 reserve call are made. So these 4 seats will be reserved: 2, 3, 4, 5. So all the seats are reserved now. So now they have called the unreserved function call with the value 5. So we will unreserve the seat at number 5. Okay, so this is the state of the array after completing all the queries. So let's analyze the function calls for reserve and unreserve. So here in this example, we are tracking it using an array. So if we track that using an array, so for every reserve call, we will have to check which is the smallest number that is available for us to reserve. So for that, we will just have to iterate the array, and if there are m number of calls for the reserve function, so and the number of seats are n, so our time complexity will go to n into m. It's go to quadratic form. The unreserved is simple because we can just directly mark the seat to -1 if we have to unreserve it. So this reserve function is very costly for us if we have a very large number of n. Okay, so now let's try to move to the next approach. So here, if we go with the brute force, which is our array approach, so our reserve function is going to take a lot of time, which is O of n cross m. So let's try to think of a better approach. Here, instead of taking an array, why don't we take a min heap? Because every time we have to get the minimum seat available from our set of seats, and when we have to just so let's say if we have to call a reserve function over number of seats from 1 to 5, what we will do is we will just initialize the min heap in the constructor with all the seats available. So initially all the seats from 1 to 5 was available, so we will add all the items in the min heap. So if we have to reserve a seat, we'll just have to priority queue dot poll the first element from the priority queue, so which would be the minimum element, which is 1. So if we have to call an unreserved function, we can just directly add that seat number to the priority queue. Okay, so this is the template which is given to us. We'll just have to fill that template. So here we decided to go with the priority queue, so we can initialize the priority queue and add all the elements. Upon reserving, we can just directly poll from that priority queue and return to the caller, and upon unreserve we can just add that seat number in the priority queue. Guys, let's try to write the code for this problem. Here we can take a queue of integer. We will make it a priority queue. Priority queue, initializing the priority queue. Okay, and initially we decided to fill up this priority queue with all the seats which are currently available. I less than equal to n. Seat numbers are from 1 to n. From 1 to n seats are available, and we are adding all the seats to the priority queue. Priority queue dot offer seat value, and when we have to call the reserve function, we can just directly priority queue dot poll. So pq dot poll will give us the smallest number from the priority queue, and as well as it will be removed from the priority queue. And upon making the unreserved call, we can just offer the seat number. Okay, let's try to run the code, then we will further try to optimize it. I'm just submitting the problem. Okay, it is submitted, but it is not that improved version. So let's try to think of a scenario where the seat number is very large and the number of queries are very small. Let's say seat number is 10 power 7, and we have to just make a couple of queries, let's say 2-3 queries. In that case, it is of no use that we are initializing this priority queue in the constructor. That is very computational heavy. Now let's try to think of a scenario where value of n is very large, let's say 10 power 7, and we have to just perform 10 queries, or maybe just reserve queries, no unreserved queries there. So in that case, there is no need to maintain a priority queue and pre-fill that priority queue using all the available seats. So instead we can just directly take a variable and keep on incrementing their value. Let's try to understand that using code that would be more clear. So we are not pre-filling the priority queue. Instead we are making a marker variable and initializing it to the 1, because first our seat number is starting from 1. So in that case, our unreserved function will look like the same way. Priority queue is offering a seat number, so in the priority queue we will just add that seat number that we have just unreserved. So now we have two possibilities. Either the marker is pointing to the unreserved seat, or maybe any unreserved seat is available in the priority queue, and the priority queue seats will always be less than the marker. Check for the priority queue value. We will check if the priority queue is empty. If our priority queue is empty, it means that priority queue is having some seat which was unreserved later on after getting reserved. So in that case, that unreserved seat will definitely be less than the value the marker is pointing to. So in that case, we can just directly call the priority queue dot poll. And the case where priority queue is empty, in that case we can just directly return the value of marker, and then after returning the value of marker, we can just increment it to the next available seat. Let's try to run this solution, and then we will make a dry run. Accepted. Trying to submit that problem. Okay, now it beats 94% of the users, so it is better optimized now. Okay, I'm trying to run that on the same example. So here in the starting, we are given seat manager with 5. So our marker is pointing to 1. The 1 is the first seat available for us, and the priority queue is empty. Okay, the marker is pointing to 1, priority queue is empty. Our seat manager function is initialized. Now reserve call is made. So we will check whether there is any available seat in the priority queue or not. If there is no available seat in the priority queue, we'll just increase our marker, and we'll just return the marker value and increment its value. So we will just return 1. Then the first seat is available, and the marker value will now point to 2. And for the further reserve call, we will just return 2, and the marker value will be increased to 3. And upon unreserved call, it is asking us to unreserve 2. So in that case, we will just add 2 in our priority queue. Now we received the reserve call, and in that case, what we have to do is we have to reserve the shortest available seat. So we see that the priority queue is not empty, so it means there is always a smaller seat available in the priority queue than the marker variable. So we will reserve that second seat by just removing it from the priority queue, and then upon the further reserve call, priority queue is empty, our marker will move to 4. 3 will also be reserved, and then after 2 more iteration, 4 and 5 will also be reserved. Now we will get the unreserved call for 5. So in that case, we will just add 5 to our priority queue. I hope that is clear to you. If you have any doubt, you can comment down below. Thank you guys.